So please, in this experiment, we are going to discuss about a inverse square law by using the photocell. How we have to calculate the inverse square law. So what is the inverse square law? First you able to see. Inverse square law through GM counter also we are going to calculate the inverse square law, and so through photocell also we are calculating the inverse square law. Newton inverse square law is there. Not only inverse square law, in electrostatistics also inverse square law is there. What is the meaning of the inverse square law? So what is the meaning of the inverse square law? Current is inversely proportional to the square of the distance. Clear? Right? By using the photocell experiment, we want to able to prove the inverse square law principle. Photocurrent is inversely proportional to the square of the distance. Clear? First you able to take the scale. One big scale you have to take. So this is the scale is there, but big scale you have to take. This one is the scale you have to keep here. So on the scale you have to keep this this light, you have to keep it. So what will happen, you able to see now, you on that. So already I told you what are the experiment. One is the power supply kit, this one is a photocell, this one is the incandescent lamp. Which lamp it is? Incandescent lamp. Various lamps are there, LED lamp, incandescent lamp, and phosphorescent lamp, fluorescent lamp, so many illusion lamp, halogen lamp, so many lamps are there in the universe. This is the incandescent lamp. The incandescent lamp will give the radiation. This radiation incident on the photocell. Photocell on cathode. So this cathode will liberate the electrons. These electrons transfer to cathode to anode. So that anode is absorbing these electrons. This electron is transferring from anode to the circuit. Clear? So that current we are going to take. So what is that current we have to find? How we able to calculate that one? We able to see. First, voltage you have to fix it. Here voltage you have to fix. How much voltage you have to fix? So at least 2 voltage you have to fix. First 2 voltage you have to fix it. So voltage first you fix it. Voltage in this diagram, same operator, 2 volts I am fixing. 2 volts I am fixing the voltage. First the circuit diagram is same. Positive of the voltage to positive of a photocell. So negative of the voltage to negative of the milliammeter. So the negative of the positive of the microammeter to negative of the photocell. This is the connection. Only 3 wires is needed. Now what is our ultimate goal? So now 2 volts I am applying, some current is displaying here. First, what is our ultimate goal? Current with respect to distance of the light. From whom to whom? Here also you have to take it as a yellow color filter, blue color filter, red color filter, green color filter. So different colors filters you have to take. First I am taking that. So green color filter I am taking. So first green color filter, what are the observations you have to see? So how much distance from is there? From here to here. So from filter to light. From filter to light. How much distance is there? This is the 7. Now you are going to take it as a 10. So first you able to take it as a 5. 5. So 5 you have to take. This is the distance is 5. How much current is there? That current you have to measure. Voltage is fixed here. So previously we are changing the voltage. Now we are fixing the voltage. Correct? Fixing the voltage. That is the 10 volts we are fixing. Now I am increasing the distance. 10 centimeters you have to change. 10 centimeters. Current is, how it is changing you have to see. 15 centimeters you have to see. So 15 centimeter. Current is decreasing. Correct? So now you have to take it as a 20 centimeters. Now 30 centimeters. Now you are able to see. If you keep on increasing the distance, you keep on decreasing the current. So that's why. So therefore what we have to conclude, I is inversely proportional to the square of the distance. So that's why this principle is satisfied through this experiment. Experimentally also this principle is proved. Now you remove this green filter. Now you have to keep the yellow filter. Now how much distance is there? 30. Now you have to change the distance. What will happen? You have to see. You change the distance. Current is increasing, no? So current is increasing. You change it. See, current is increasing. You away from that. Current is decreasing. Correct? You away from that, current is decreasing. So this distance is inversely proportional to the current. Distance is inversely proportional to the current, correct? So now next you have to take one more filter, red filter you have to take, red filter you have to keep. So you able to keep it as a 5-meter distance, 5-meter distance, 10-meter distance, and 15-meter distance, and 20-meter distance, and 40-meter distance, and 60-meter distance, like that you have to keep. You able to find out the distance values you have to find out, and blue color sheet that current value, and green color sheet that current value, yellow color sheet that current value, and red color sheet that current values. So this 1 by d square you have to do. This is the distance, 1 by d square you have to do. That value you have to take on x-axis. These currents you have to take on y-axis. For each and every color, if you increase the distance, what will happen? So you are decreasing the current. So you are decreasing the current. Your current is decreases. Clear? So the reciprocally happen. So through this, we have to confirm the inverse square law is verified. So photocell experiment, through photocell experiment, not only VI characteristics, inverse square law also satisfied. So this is the experiment of the inverse square law by using the photocell. Please share, subscribe, and watch and touch the bell button. Thank you.